and welcome back to the Electrical Building Design Show. My name is David Robinson, and I'm your host. Today, I want to talk about the opportunity that you have with building information modeling and voltage drop calculations. Voltage drop is something that's going to come up in all of your projects. You need to make sure that the voltage drop on all of your feeders, all of your branch circuits is not too high. Generally, where you're going to be checking the feeders that look like they might be an issue, you might look at some of the larger branch circuits. Building information modeling actually gives you the opportunity to do this faster, more precisely, and more completely than you're doing right now. So building information modeling actually has the opportunity to make this a better process for you. Building information modeling is not something that electrical engineers generally think of as something that's really helping them. It's something that is forced on us by architects, but it actually has opportunity to be super useful if it's implemented properly and you're using the information as an electrical engineer for the stuff that you need to do and that you need to calculate. So let's talk about voltage drop calculations. When you're doing BIM, you're going to be laying out all of your devices in your model. You're going to be putting them in the 3D model, locating where they are, both your panels, all of your distribution equipment, your switch gear, and the receptacles and your light fixtures. Everything's going in your model, and you're connecting it together. That should all be happening in BIM. You can then take that information, and you can use that for voltage drop. You have all of the connections, so you know what's connected. So you're probably doing your voltage drop in Excel. You might be stepping out to another third-party package. You have to put all of this information in there. Again, you have to put in all your panels. You have to connect things. You have to model your large loads. All of that's already been done in BIM. You don't want to do that again. You want to transfer that information from BIM to your calculation package. You want to look for ways to transfer that data. If it's an Excel spreadsheet that you wrote, you're probably going to have to write some scripting to transfer that data for yourself. If it's a third-party package, you're going to be looking for what they have available to you to transfer the data. What kind of data do you want to be transferring? You want to transfer all of the devices. So you should be able to transfer your panels and your transformers and everything that's connected to them and how they're connected to each other. And it doesn't need to be just the large loads on your branch circuits. It can actually be everything. When you're transferring the data automatically, you're laying it out already because you have to circuit it. You want to create your panel schedules in BIM. You've already got all this information. Why not calculate voltage drop on everything? So we're no longer limited to doing voltage drop on the feeders that we suspect might be an issue, on the branch circuits that look like they're going to be a problem. Just calculate it everywhere, knowing, and then you can know that you've calculated voltage drop on your entire project and know that that the calculations can point out where you're going to have issues. You don't have to worry about which feeders and which branch circuits are going to be a problem anymore. Doing everything just lets you know you've checked everything. You know which ones are a problem and which ones are not. You can pull all of those lengths from BIM over to your calculations. You have everything laid out in 3D. You know where it exists. You can pull lengths for voltage drop. These lengths maybe aren't going to be the precise, accurate value. You're not going to cut a wire based upon this. You can get close enough to make sure that your voltage drop isn't too high or that it's within an acceptable range. You can also transfer all of your loads because all of those loads are going to be specified in BIM on your devices. You can transfer those loads to your calculator because that's going to be an important part of your voltage drop calculation. You need to have the distances. You need to have the load to actually do that calculation. You also need to have the impedance on those wires. Where that impedance stores is kind of an open question. If you have a well-formed building information model, you could put the information in there and transfer it. It's a question of whether what you're working with actually has a place to put the impedances and be able to size the wires consistently in a manner that gives you enough control. Maybe that is happening over in your calculation package. You want to think through where that information is being stored. It's going to be best if you can actually have it in BIM and transfer it to your calculations, but that might not be a possibility depending on what your specific use cases and what pieces you have in place. Building information is the hot buzzword for the last 20 years in the industry, and it's something that's always driven by architects. It has so much power for electrical engineers if we can just actually use it for the pieces that are helpful for electrical engineering. Voltage drop is one of those places that has a huge potential to benefit from building information modeling. Look to use the information in your building information modeling to drive your voltage drop calculations. Your calculations can be more consistent, They can be more complete. They can keep up with the changes in your design a lot better. There's a lot of opportunity for BIM to actually help electrical engineers. We just need to start using it in places where it makes sense, like voltage drop calculations.